Recording in progress.
Hello there, everyone. So today we are going to solve one of the past paper. This is computer science P3. So we'll be solving over here is 031. Okay, so here we go. I'm Mr. Saem, so I'll be solving one of the past paper with you. Okay, so we have this first question. Numbers are stored in different computer systems by using floating point representation. System 1 uses 10 bits for the mantissa and 6 bits for the exponent. 2's complement form, right. System 2 uses 8 bits for the mantissa, 8 bits for the exponent. 2's complement form for both mantissa and exponent. Calculate the normal point representation for 113.75 and show how it would be represented in the two systems. Okay, right. So we have over here is 113.75. So first of all, we need to convert this into our binary. So if I convert 0.575 into binary, I would actually have is dot 1 1 and preceding zeros, right? Well, that's why, because this is actually 1/2, this is 1/4. Technically speaking, this is actually equal to 0.75, right? And on this side I actually have is this. So I'll have is over here, if I need to add this up, I will get 1, so 1 2 4 8 16 32 64 and 0. So if I add this up, this will be actually be 113, 64 plus 32 plus 16 plus 1. Okay, so this is what I get. So this is my binary now, but this is not in normalized form. Now this is where the important point comes in. If I have to convert this into normalized floating point representation of this denary value, we actually have to normalize it. So 1 2 3 4 5 6 7. Okay, remember this, that over here it should either be 0 1 or 1 0. It cannot be 1 1 or it cannot be 0 0. Remember this rule. So technically what I have over here is for my mantissa. Okay, so since I have floated 7 points, my exponent will be 7. Saying that my exponent will be 7 means is I'll have 1 1 1 0 0 0, because this is actually 7, right? So this is like 1 2 4 4 plus 2 plus 1 is 7, and all I have to do is I'm going to write this over here. So I'll have is 0, right, and 1 1 1 0 0 0, right, and 1 1 1, right. All this I have to write this all together, all this together. Remember that. Okay, so that's the way. Okay, I'm repeating again. The mantissa will be derived through this. My mantissa will be 0 1 1 1 0 0 0 1 1 1 0 0. So I have to fit this either in 10 or 8. So if I fit this into 8, I would actually get is 0 1 1 1 0 0 0 1. Yeah, I will not have these two, so my precision will be lost in this case. And in this case I will have is 1 1 1 0 0 preceding zeros I'll have over here, right? Okay, so let's come to the next part. Explain the problem that will occur. Obviously, I just like I told you, it will be truncated. The digits that I have on the right hand side will be removed, and so that obviously the accuracy, precision will be reduced. Okay, so we have the following. Let me zoom back. Okay, supervised training simulates the data processing capabilities of human brain to make decisions. Okay. Okay, right. Then we have is enables learning by mapping input and output based on example of input output pairs, right. Enables information related to errors. Okay, so this would be reinforced. Okay, enables information related to errors produced by neural networks. This is not here. This is actually artificial neural network. Deep learning, so enables learning in an interactive environment by trial and error. Okay, so what we have is and enables learning by allowing the process to discover patterns that were previously undetected. Right, so we have over here enables learning by interactive. Okay, so this actually enables learning by allowing the process to discover patterns that were previously undetected. Unsupervised learning enables learning in an interactive environment by trial. This will be your reinforced learning. Deep learning would be your this simulation data processes, and supervised learning will actually be this, right? Okay, right. So supervised, obviously, supervised would when you input and output at the same time. Deep learning is simulates data processing capabilities of human brain. Okay, when computers start behaving like humans and they can make decisions, that's deep learning. Describe the process of A star algorithm and Dijkstra algorithm. Both of these are actually used to find the shortest path to resolve a problem. This would actually reduce the cost and time. Remember that. Okay. A hash algorithm is used to calculate the storage location for records in a random access file. It calculates hashed values by using function modulus 3. The function modulus gives the remainder after an integer division. Okay, so actually we have to do is we have to find the modulus and the remainder. So the first one obviously is 1. In this case we are going to get is so a hashing algorithm. I'll just explain what hashing algorithm is. In this case we'll get 0 because it will be directly divided by it. Okay, and then we're going to get 2 in this case. So we have to find the remainders. Hashing algorithm works quite the same way as your what do you call that, your check digit. Okay, because you have to do the calculations of the numbers, and then you break them up, and ultimately you come up with the final value. This final value that you get is actually used to determine what those digits are made up of. Hashing algorithm tends to be a much safer way, obviously, because there's no going back here, so it's much more safe, right? You'll find lecture of hashing algorithm. I'll share that in the videos below. Describe what happens in relation to the storage retrieve of record or file when the calculated hash value is a duplicate of the previous value. Well, in case if there is a duplicate value, obviously the first thing that you would have is a collision. Okay, they'll simply collide, and then the other problem would be that well, describe what happens. Okay, what happens? Well, it will search in a linear way. It will keep on searching. If it does find one, fine, the match would be made. If it's unable to find one, it will obviously return back no value. And what it would do is it will also try to utilize the overflow. Okay, if there was an overflow value, it would try to use that as well. So okay, so this is the way it will work. It will search linearly. It will try to find the next word space if it's determined. Okay, if it doesn't match. Okay, and it will close, obviously. If it's not fine, the file, it will obviously close the file, and nothing will happen. So obviously if it does determine the storage location, it will obviously try to fetch that record. Okay, this is the way it works. The two description of UDT types are here. Give appropriate declaration. So we have to declare, first of all, is this. So we can simply call this type. We can name this as type prime, and we can just define these in bracket and comma separated value. So this is how actually you define is a list. Day type to buy a day in a week. So this is actually, we're talking about the pointer. So we can have over here is a type of the week. So we can define is as, let's say, we can find this type of week. Okay. Day. right? We can define this way. A day of the week, this is the pointer that can define the type day pointer. State a reason where appropriate to use circuit switching. Switching, there are two kinds of switching. We have packet switching and circuit switching. Circuit switching is technically used in voice calls. Circuit switching um, uh, needs an entire line, full dedicated line to be used, which cannot be used elsewhere. So it has much more better flow of data. Okay, so for real time, good reason. Okay, for audio, it will be very good. There won't be any delay, and you will get is full bandwidth. Okay, in this particular case. So yeah, why circuit switching is used. Benefit one obviously is you can get is better voice call. It's real time, right? We get dedicated line. Okay, we can by for that particular reason. Drawback obviously it would be is there could be time delay. Okay, which is the latency delay as well. It could be slow. And then the other drawback of your circuit switching could be in wastage of bandwidth. Okay, since if someone is only consuming part of the bandwidth, the rest of the bandwidth will not be used. Okay, the rest of the bandwidth, or yeah, which in one sense that it can only be used by that one person and no one else can use it. So it's all total wastage. Okay, then we have this several syntax diagrams, operator, digit, symbol, letter, password, right? What we have to do is state whether each of the following passwords is valid or invalid. So we have over here is a letter, digit, symbol. So we have the letter, digit, symbol that's valid, letter, uh, no, that's invalid, and letter, digit, that's valid, right? Okay. Complete the following. So symbol we have is symbol would be the following. So we have is dollar sign, or I hope I have it in front of me. In fact, let me open this up uh, question on my one as well. So we have the following. Okay, what was it? We have dollar. We have and we have is ample. Oh, sorry, was dollar. We have percentage. We have and, or we have at the rate of, or we have the fact, right? In case of symbol, we actually have is it's A or D or P or R or Y, right? An identifier begins with one or more letters, followed by zero digits or one digit. Valid letters and digits are shown in this diagram, draw a diagram. Okay, for this, what we can do is, let me back the question. Okay, right. So actually, it has to be like this way. So we are going to have is a letter, a digit, right? So that's your identifier. So obviously, a letter in this case could be repeated. Your digit could be repeated. But the important thing over here is where letters are shown there, followed by zero digit or one digit or more digits. So you can also have is multiple digits as well, right? Complete the formula map. I don't need the, I guess we have the following. So complete the formula map, K map for the following Boolean question. So you can see over here is I am A inverse, B inverse, C inverse, C inverse. So this actually would come here because 0, 0, 0, 0. Remember one thing, when C inverse, it's 0, or when 0, it's inverse. And when it's 1, with this, okay, if you don't know. So in this case, it would be over here. Why? Because I have A inverse, B inverse, and C inverse D. So this is C inverse D. So I have it here. Next, this one. This is A inverse B, which is this, and C inverse D inverse, which is this. This one is A inverse B inverse. So this is this one. This one is A inverse B this. And then we have A, B, C, D inverse. So we have A, B, C, D. Right. So if we have to make something will be asked, we will actually have this. So we'll have first is this group, and then we'll have another this group. Remember that. Now, why is that so? That is so because we are allowed to make groups in 2, 4, 8, 16 maximum, right? So we can make a group of 2, we can make a group of 4, but at the same time, it's that we have to make maximum groups as well. So 2 maximum groups are, this is how I can make one. I can't make a group of 6 over here, right? So done this one, write a Boolean expression from your answer in part B, simplify. If we simplify this, what do we have? So let's talk about this part. Okay, I'm talking about this. If I talk about this circle, what do I have? Over here, we have to look at either both are 0 or both are 1. What do I mean? So this thing's values. Over here, what I have is 0, 0. So in this case, I have is so AB is 0. So A inverse. Okay. And over here I have is C, right? This is B. Right. So what do I have over here is A inverse is here. As you can see over here is A is 0, 0, right? And if I look at C, C is 0 here and C is 0 here. D is not here. And as far as B is concerned, okay, right? So B in this case, 0, 0, this is 0, this is 0, A is 0, and this case 0, 0. So this would actually be is A, C, A inverse, C inverse. And then plus, if you look at this case, I have 1, 1. 1, 1 means B is 1, right? So I'll have B as it is. And in this case, I have C, C inverse. So let me explain again. In this particular circle, now I have, let me see some of it. I'm talking about it. I'm talking about this one right now. This one, if you see, I have A as 0. Okay. So, and this is 0. So it's 1, 1, 1. In all these cases, A is 0. B changes to 1. And if I look this way, in this way, I have D is changing. C, this one and this one remains the same. That's why I have C. In this circle, again, look, I have B. So B is what? B is 1 and 1. So B remains like that. See, it's 1, 1. And as far as this one is concerned, this right, over here I have C. So you see, C is 0, 0. So I get C inverse. D is again, D is 0 here and D is 1 here. I won't have this. Okay. So I won't have A here. Why won't I have A here? Because A is 0 and A is 1. I get this. What if I want to simplify this? If I want to simplify this, I would say A. No. I would simply say different colors is fine. So I would actually do it. If I have to simplify A plus B C dash, I will just take out C dash and I'll have A inverse plus B. This is the way we'll do it. Outline the effects of massive parallel computing. When we talk about massive parallel computing, we also compare it with supercomputing. But remember that all this don't work massively. But anyway, we are not doing that comparison. Massive parallel computer means that you have lots of computers that lots of these are like thousands and go in lot, obviously thousands. So they are interconnected to each other in such a way that they process different modules. So they process as much information as We can. So first of all, we need to talk about it that they are actually they are interconnected. That's one of the most important things. Then we have to tell is that they share their pro processors. Okay, right, right. That's how they actually work. And we can also talk about is that uh, modules, or we can talk about load is 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 shared equally to speed the process, right? Encryption is used to alter data into a form that makes it meaningless and restricted. Describe the purpose of asymmetric encryption. Asymmetric encryption uses a private key and a public key both. This is one of the way to make the data as very secure, because when someone has both of these keys, only then the person will be able to decrypt it. Identify two benefits and two drawbacks of quantum cryptography. Okay, quantum cryptography, I have a separate lecture of that. I'll be discussing it in more detail someday else. It actually, in a very simple, in a very summarized, I'll tell you is that there are filters and we can actually use filters. These filters are left diagonal, right diagonal, horizontal, and vertical. So, okay, right? So your zeros and one actually pass through these filters, and a person at the other end, or machine at the other end will actually set these filters accordingly when someone has to receive the data. Okay, contributing benefit of is very simple. That's one of the advantage. Benefit two is obviously it's very fast. Okay, a drawback of this is obviously very expensive, and this one is another thing that should be used for long distance. Not more than 100 right now. There might be repeaters can be used, but repeaters have not been developed for quantum cryptography right now. Keep that in mind. Okay, then we have is a pseudocode algorithm who copies an active account like active file txt to an archive txt file, right? One at a time. Right. So we're copying files from one file to the other. Any blank lines found in the active context file are replaced with the word this. Okay. So we have to do is open account this, open account. All right. Okay. So we'll do is we will open file. Sorry, missing account. Open file. We have to open a file, not the archive one. So done. Or archive is done. Active file has to be dot txt. Right. Run while not end of file. Okay, 60 while txt we can write is account not present, otherwise display the account. And then what we have is close file. We have close the file. Which one? Active file dot txt. Right. Okay. Pseudocode is to be written to implement Q abstract type with items of the string type. This will be implemented using for information, front pointer, rear pointer, length, q. Points at the end, right, 1D. Constant define this, 60. Okay, right, 60 items, write a pseudocode to declare max size. So obviously we can do is we can have to declare constant, which is the max size, which is 60, right? Which is 60, not equal to, use the arrow. So we have to declare is we have to declare is the front pointer Okay, and this has to be an integer. We have to declare, write this again, we have to declare is the rear pointer integer, declare length as an integer, fine, and then we have to actually declare our q, which would be array, and this would be 1 to 60. So that's the way to do that. Okay, right. So see you in the next class where we'll continue this.